Hello guys, welcome back to Maths with Arjun channel. In the previous video, we have completed till exercise 6.2 of class 8th Maths NCERT, and in this video we are going to take the concept to further level. So without wasting any time, let's jump into the video. So first concept is of square roots. So what is square roots? Square root is simply inverse of finding the square of a number. Let's understand more this by taking an example. So we know that square of 4 is equal to 4 square is equal to 16. Now if we are asked to find the square root of 16, in this way we represent the square root. So square root of 16 would be square root of 4 square, which is equal to 4. So if someone asks you square root of 16, so it would be 4. Now there are different methods of finding square roots. So first method is finding square root through repeated subtraction. So what we do is we repeatedly subtract the first odd natural numbers from the number till we get 0, and when we get 0 we count the number of steps in which we got the answer as 0, and the number of steps gives us the square root of the number. Let's see how we get. For example, we have to find the square root of 81. So what we are going to do, 81 minus 1 is equal to 80. Similarly 80 minus 3 is equal to 77. Similarly 77 minus 5 is equal to 72. 72 minus 7 is equal to 65. 65 minus 9 is equal to 56. 56 minus 11 is equal to 45. 45 minus 13 is equal to 32. 32 minus 15 is equal to 17. And finally 17 minus 17 is equal to 0. So what we have done is that from 81 we subtracted successive odd numbers starting from 1 and obtained 0 at the 9th step. So square root of 81 would be 9. Next way is finding the square root through prime factorization, or finding the factors of the number. And we make the pairs and consider the number 2 times as 1. So first of all we have to find the square root of 324. So we know how to find the factors. So 2 162s are 324 and 2 81s are 162, and 81 gets divided by 3. So 3 27s are 81 and 3 9s are 27, 3 3s are 9, and finally 3 1s are 3. So factors of 324 are 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. And we have to make the pairs. So 2 multiplied by 2 we consider as 2 because we are taking the square root. 3 multiplied by 3 we consider as 3. And 3 multiplied by 3 pair we consider as 3. So 2 3s are 6, 3s are 18. So square root of 324 comes out to be 18. Let's solve some of the questions. So it asks, is 2352 a perfect square? If not, find the smallest multiple of 2352 which is a perfect square. And after that we have to find the square root of the new number. So we are going to find the perfect square using prime factorization method, which I have discussed just before. So 21176 is a 12352, 2588 is a 1156, 2294 is a 588, 2147 is a 294, 349 is a 147, and 77 is a 49. So factors of 2352 comes out to be 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by 7. So we can see that 2 multiplied by 2 has pair, 2 multiplied by 2 pair, 7 multiplied by 7 pair, and there is one 3 left out which has no pair. So 2352 is not a perfect square, because if 3 had a pair then it would have been a perfect square. So if 3 gets a pair, then that number would be a perfect square. So if we multiply 2352 with 3, then 3 gets a pair, and 2352 into 3 is equal to 7056, which makes it a perfect square. And we are asked to find the square root of this number. So it would be simply 2 multiplied by 2 multiplied by 3 multiplied by 7. We have just multiplied 3 to 2352, so 3 gets a pair. So 3 multiplied by 3 comes out to be 3, as we are finding square root. So square root of 7056 comes out to be 84. Next question says, find the smallest number by which 9408 must be divided so that the quotient is a perfect square, and find the square root of the quotient. So we are going to find the square root of 9408 by using prime factorization method. So 24704 are 9408, and 22352 are 4704, 21176 are 2352, 2588 are 1176, 2294 are 588, 3147 are 294, and 77 are 49 finally. So the pairs are 2 multiplied by 2, 2 multiplied by 2, 2 multiplied by 2, 7 multiplied by 7, and 3 is left as alone, as it does not forms the pair. So if we divide 9408 by 3, then the remaining would make a pair. So 9408 divided by 3, which is 3136, would be a perfect square. So the required smallest number which must divide 9408 to make it the other number perfect square is 3, and it is asked find the square root of 3136. So it would be 2 multiplied by 2 multiplied by 2 multiplied by 7, which comes out to be 56 by finding the pairs. Next question says, find the smallest square number which is divisible by each of the numbers 6, 9 and 15. So what we do in such cases, first we find the lowest common multiple, that is LCM of the given numbers. So LCM of 6, 9 and 15 comes out to be 90, and you can see the LCM solved on the right hand side of the screen. So LCM comes out to be 2 multiplied by 3 multiplied by 3 multiplied by 5. Here 3 has a pair, but 2 and 5 does not have a pair. So if 2 and 5 gets a pair, then the number which thus formed would be a square number. So if we give 1 to 2 and 1 5 to 5, then what we get as 90 gets multiplied by 10. It gets 1 2 and 1 5. So we get the number as 900. So smallest square number which is divisible by 6, 9 and 15 comes out to be 900. So let's solve some questions of the exercise 6.3. So it says, what could be the possible digit of the square root of each of the following numbers? That is ones digit. So its first part says 9801. So unit digit of 9801 would be either 1 or 9. As the numbers having the unit digits as 1 or 9s, squares comes out to be equal to ones at the unit, so it's reverse. Next part says 99856. So unit digit of 99856, square root would be 6. Next part says, without calculating, find numbers which surely are not perfect squares. This we have solved previously also, and it's again here. So we know that the numbers ending with 0, 2, 3, 7 and 8 are surely not perfect square numbers. So first number is 153 and it ends with one of the numbers which when comes at the unit digit makes the number a non-perfect square. So 153 ends with 3, it is not a perfect square. Next number is 441. It ends with 1, which is not one of the numbers which when the number ends with a unit digit make it non-perfect, but 441 we know that is a perfect square. Next question says, find the square root of 100 by repeated subtraction. So let's see. So 100 minus 1 comes out to be 99. 99 minus 3 comes out to be 96. 96 minus 5 comes out to be 91. 91 minus 7 comes out to be 84. 84 minus 9 comes out to be 75. 75 minus 11 comes out to be 64. 64 minus 13 comes out to be 51. 51 minus 15 comes out to be 36. And 36 minus 17 comes out to be 19. And finally 19 minus 19 comes out to be equal to 0. So here we have performed subtraction 10 times. So square root of 100 comes out to be 10. Next question says, find the square root of the following numbers by prime factorization method. So we have to find the square root of 400. So we know that 2 hundreds are 400, 2 hundreds are 200, 2 50s are 100, 2 25s are 50, 5 5s are 25, and finally 5 1s are 5. And we have to form the pairs. So 2 into 2 1 pair, 2 into 2 1 pair, and 5 into 5 1 pair. So 2 2s are 4, 5s are 20 is the square root of 400. Next part is 529. So 529 is only divisible by 23. So 23 23s are 529. So 23 is the square root of 529. Next question says, for each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square number. And also find the square root of the square number so obtained. This type of questions I have already explained in the exercise. So let's see how we solve it. So the first part is 252. So 2 126 are 252, 2 63s are 126, 3 21s are 63, 3 7s are 21, and finally 7 1s are 7. So let's see which numbers form pair and which not. So 2 into 2 forms pair, 3 into 3 forms pair, and 7 does not forms a pair. So if 7 gets one pair, it makes a perfect square number. So if we multiply 252 by 7, it comes out to be 1764, which is a perfect square number. And we have to ask the square root of the perfect square number. So square root of 1764 would be 2 multiplied by 3 multiplied by 7, which comes out to be 42. Next part is 180. So 2 90s are 180, 2 45s are 90, 3 15s are 45, 3 5s are 15, and 5 1s are 5. So let's see which numbers form pair and which not. So 180 comes out to be 2 into 2 1 pair, 3 into 3 1 pair, and 5 remains alone. So 5 needs 1 pair to make a perfect square. So we multiply 180 multiplied by 5 so that 5 also gets a pair, which makes it is equal to 180 into 5 is equal to 900, and square root of 900 comes out to be 2 into 3 into 5, which is equal to 30. Let's see next question. It says for each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the number so obtained. Let's solve it. So it says 252. So 2 126 are 252, 263 are 126, 321s are 63, 3 7s are 21, and finally 7 1s are 7. So we find 252's factors and pairs. So 2 into 2 1 pair, 3 into 3 1 pair, and 7 alone. So if we divide 252 by 7, then we will get a perfect square number. So 252 divided by 7 comes out to be 36. We are asked to find the square root of 36, which comes out to be equal to 6. Next part says 396. So 2 198s are 396, 2 99s are 198, 3 33s are 99, 3 11s are 33, and finally 11 ones are 11. Let's see which number forms pair and which stays alone. So 396 is equal to 2 into 2 1 pair, 3 into 3 1 pair, and 11 remains alone. So if we divide 396 by 11, we get a perfect square. So which gives 396 divided by 11 is equal to 36, and square root of 36 comes out to be 6. Let's see next question. Question number 7. It says the students of a class 8th of a school donated 2401 rupees in all for the Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class, and we have to find the number of students in the class. So this is a word problem based on square and square roots. So let the number of students is equal to x. Also it says the number of students in the class is equal to number of rupees donated by each student. So each student donated would be is equal to rupees x. So total money donated would be equal to number of students multiplied by money donated by each student, which would be equal to x into x, which makes it as x square. It says that 2041 rupees is donated all. So x square comes out to be equal to 2401, and x comes out to be equal to square root of 2401, which you can find by using the prime factorization method, which comes out to be equal to 49. So number of students comes out to be equal to 49. Next question says 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. We have to find the number of rows and number of plants in each row. This is the same question type as we have solved question number 7. So let number of rows is equal to x, and number of plants in each row would also be equal to x, as number of rows and number of plants in each rows are equal. So number of rows equal to number of plants would be equal to x into x square would be equal to 2025. So number of rows equal to number of plants would be equal to square root of 2025, and you can see how we have solved using the prime factorization method. So it would be 3 into 3 1 pair, 3 into 3 1 pair, and 5 into 5 1 pair, which comes out to be equal to 45. So number of rows equal to number of plants in each row would be equal to 45. Next question says, find the smallest square number that is divisible by each of the numbers 8, 15 and 20. So this type of question we have already solved. So what we do in this is, first we solve the LCM and then multiply it with the numbers which do not have a pair. So LCM of 8, 15 and 20 we can solve using the prime factorization method. Comes out to be 2 into 2, and 2, 3 and 5 do not have pairs. So LCM comes out to be 120, and 120 is required to be multiplied by 1, 2, 1, 3 and 1, 5. So they also get a pair. So 120 multiplied by 2, 3 is 6, 5 the 30, comes out to be 3600. So the smallest number that is divisible by 8, 15 and 20 each is equal to 3600. So that's it for today. So kindly like, share and subscribe the video. And if you have not watched the previous videos of this series or any other previous chapter, so kindly go and watch it. So that's it for today. Thank you so much.